Testing. Assalamualaikum. Dr. Wani dengar tak? Okay, thank you. Dr. Wani nanti tolong postkan dia punya ni ya, Dr. Wani ya. Apa tu kehadiran? Boleh ke?
Assalamualaikum.
Assalamualaikum.
Hah? Jayut. Jayit.
Gambar Dr. Hamizah nampak kabur sikit. Memang ni ke?
Kabur doktor?
Agak kabur sikit. Lighting belakang tu.
Lighting belakang tertutup ke ni?
Mungkin. Tak apalah. Okey je.
Dah tutup tingkap Okay. Lampu bilik malap lah doktor. You nak report lagi lampu? 2 lagi jadi. Satu.
Dr. Sumarni, 14 hari bulan Oktober kita ada aktiviti tak Dr. Sumarni?
Bila?
14 Oktober.
Tak dengar.
14 Oktober.
14 Oktober setakat ni dalam takvim tak ada apa-apa lagi.
Tak apa lagi ya. Sebab ada permintaan kawan-kawan kita nak buat Kolokium pada 14 Oktober. Maksudnya diawalkan daripada tarikh biasa. Jadi kalau tak ada masalah program di jabatan, mungkin boleh beri laluan kepada mereka. Tapi kalau ada program lain yang memang dah dirancang dari awal, berkemungkinan tak bolehlah nak buat.
Setakat ni tak ada apa-apa 14 Oktober. Yang ada November je lah open day tu.
Okay. Thank you. Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera semua. Semua dapat dengar
Dengar Doktor.
Okay, sebelum kita mulakan majlis, kita baca Ummul Kitab Al-Fatihah. Pembentang pada petang ini ialah Dr. Nur Hamizah Abdul Ghani. Latar belakang pendidikan beliau telah mendapat sarjana muda matematik industri daripada UiTM Skudai. Seterusnya sarjana sains matematik daripada universiti yang sama dan Dr. Falsafah dalam bidang matematik optimization dari UNIZA. Tajuk pembentangan Dr. Hamizah pada petang ini adalah Modifications of Conjugate Gradient Method in Solving Unconstrained Optimization Problems. Jadi untuk tidak membuang masa, saya mempersilakan Dr. Hamizah untuk membuat pembentangan. Dipersilakan Dr. Hamizah.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, boleh dengar tak suara ni?
Boleh, tapi rasa macam ada tengah hujan je di sana Dr. Hamizah?
Hujan. Saya kat fakulti ni.
Oh, okey. Ya, samalah kita. Ya, memang dengar suara tapi dengar juga suara hujan.
Dengar suara hujan. Okay, saya start ya.
Silakan.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. So first of all, thank you to Dr. Agus and everyone here. So today I am Nur Hamizah binti Abdul Ghani. Will present for the Kolokium session today, and my topic is about modifications of conjugate gradient method in solving the unconstrained optimization problems. Right. So actually this is a part of my work during PhD under supervision of Prof. Mustafa from UNIZA and also Dr. Muhammad Rifai from UiTM Trendano. So this is the slide content of my presentation today. I will start with the introduction and then move to what is conjugate gradient method. And then the algorithm of conjugate gradient method or known as CG method, problem statement, research objective, scope of the research, methodology, numerical result, and last one is the conclusion of the study. Okay, this is for introduction. Can you see my slide? I am at the page of introduction.
Ya.
Right, so let's start with the introduction. Talking about optimization, it is a subject that is widely used in all fields, right? Mathematically, optimization is a decision-making tool that concerned with the study of maximization and minimization of mathematical function. And then the optimization has been developed to solve two type of class, which is a constraint and also unconstrained problem. So for my research, I will limit the scope. I will focus or I will concern on the unconstrained optimization problem, and this is the general form of the unconstrained optimization, which is minimize fs. Fs here is referring to the real value function, and then this problem or this function will be solved by using the iterative method, which is sk plus 1 equal to sk plus with alpha k dk. Sk plus 1 is referred to the next iteration point, next iterate point, Sk is the current point, alpha k is the step size, and dk is the search direction. So in the iterative process, we do the convergent test to make sure that the next iterate point, the function of xk plus 1, the next iterate point, possess smaller value function compared to the function at the current point, right? And then the process is stopped when it satisfies this stopping criterion, right? I choose this value, norm gk is less than 10 power of -6, right? This is suggested by many researchers. And our aim of this process is to determine x star here, which is the optimal solution or the minimizer which give the most minimum value of the function, so that this function will be minimized at each iteration by using this condition, the convergence test, until the optimal solution is achieved. Right. Okay, so in optimization, we use the iterative method, where this is the formula, right, to get the solution. And alpha k here is referring to the step size. So the process required to compute the value of alpha k, which is the step size, we call it as line search, right? So as you can see here, there are the type of line search, exact line search, and also inexact line search. Exact line search give the exact value of alpha k. Meanwhile, for inexact line search, it will give the approximate value of alpha k, right? And then for the inexact line search, there are several famous line search that has been proposed, which are Gaussian, Amateur, and Wolf. So for my study, for my scope of the research, I will apply for both exact and inexact line search. For exact line search, I will use this formula of exact line search, and for inexact line search, I will use the strong Wolf power line search, right? And this line search also has been used by many researchers. Okay, next is if you look at on the iterative method, we have dk here. Dk here represent as search direction, right? Search direction. So as you can see in the table below here, right? Different search direction will lead to different method in optimization, right? The first search direction is known as steepest descent method, right? Steepest descent method. And as you see here, the formula for decay by SD method is decay equal to negative gk. Gk here represent as the gradient, right? The formula is simple, and it just only use negative gradient, right? And then means that it only use the first derivative in the calculation to get the for the search direction, right? And then if we compare the performance of steepest descent with the others method, this one is the most slowest lah, the slowest method in terms of the performance, right? The performance slowest to converge to the solution point. Okay, and then number 2 is search direction by Newton method, right? This is the general equation of search direction by Newton method. Dk equal to negative Hessian inverse gk. So it involves with Hessian here, right? So for the Newton method, it involves with the computing the exact inverse Hessian matrix. Exact inverse Hessian matrix, where it requires second derivative in the calculation compared to steepest descent. It only requires first derivative, only negative gk here. So Hessian, it will involve with second derivative, right? In terms of the performance of Newton method, it said based on the previous researcher, right? It said that the Newton method is better compared to the steepest descent, right? But because of the existence of Hessian here, Hessian matrix, it will lead to the high computation or time consuming to reach to the solution, time consuming for the Newton method. And also for the Newton method, it has local convergence. Local convergence means that the solution obtained by this method, it may necessary to be the most optimal solution because it will converge to the local solution, right? That is for Newton method. And then for quasi-Newton method, search direction for quasi-Newton method, it is actually is developed based on Newton method, right? The difference between quasi-Newton method, yeah. Saya dekat a table of search direction. Slide number 3.
Macam kalau dalam mod ni tu, dalam mod presentation, mod ni.
Ini nampak? Slide 5. Table of search direction. Okay. Okay, we start quasi-Newton method. So as you see, quasi-Newton method is developed based on Newton method, right? For Newton method, it involved with computing the exact value of Hessian metric, right? But for quasi-Newton method, it only used the approximate of inverse Hessian metric. Means that the calculation process is going to be more faster compared to the Newton method, but still it's still slower, especially if we use the large scale problem because of the existence of Hessian matrix here. And similar to the Newton method, quasi-Newton method also is known as the locally convergent, right? So that the optimal solution for this quasi-Newton method is not always guaranteed because it will converge to the local solution, right? And the last one is CG method, conjugate gradient method, or we said as CG method for the conjugate gradient method. And this is the formula for search direction of CG method. Dk equal to negative gk plus beta k dk minus 1. Gk is the gradient. Dk here is represented as the coefficient of CG, and dk minus 1 is the previous search direction, right? Previous search direction, right? So for CG method, it is actually it doesn't involve with Hessian matrix, right? So it doesn't need to have second derivative there. And then it is also is improved from SD method actually, right? Negative GK here. The difference is we have add scalar beta k and also dk minus by 1. Search direction or dk minus 1 is search direction from the previous point. Alright, so this is the illustration, right? The performance of steepest descent method, SD method, and CG method. CG method is improved from SD method, so I will show you the comparison performance between these two methods, right? So here is the formula for SD method, and this one is the formula of CG method, right? So as you can see here, CG method is said to be have fastest convergence compared to the SD method, right? Say, as you can see the figure here, the outer layer, we have the global solution, which is here, right? Let's say we use the similar function, right? We use the similar function to solve by both of this method. So for SD method, here is the starting point, right? It require almost 5 iteration, 1, 2, 3, 4, and 5. 5 iteration to converge from initial point to the solution point, to the global solution. Compared to CG method, it's only require 2 iteration, 1 and 2 iterated here to converge to the solution point. So in terms of number of interaction, this one CG method is going to be fastest. Right, this is just illustration. Alright, so for my study, I will focus on CG method, right? And this is the advantages of CG method based on compared to the other unconstant optimization method. The first is CG method is improved from SD method. Yeah, CG method is improved of SD method, and it overcome the slowest convergence of SD method. And then CG method is also simple, right? And known as a fast convergence method. However, among of all the unconstant optimization, of course, quasi-Newton method QN is the fastest one. But because of quasi-Newton method, it involves with Hessian matrix, right? So the computation of quasi-Newton is going to be complex, right? And it may be difficult to obtain. And then for CG method, it has low memory storage. Low memory storage means that it only involves with simple calculation compared to quasi-Newton method and the others. And it only require first derivation and avoid evaluation of Hessian matrix. If we look at on the formula of CG method, doesn't have a Hessian matrix there, right? And then it also is ideal for solving large scale problem, large scale optimization, right? So this is the class of CG method that which are classical and hybrid CG method. Actually, if you explore on CG method, we other than classical and hybrid CG method, we have another class. You can see we have scale CG method, spectral CG method, 3-term, 4-term, and so on, right? So it is depend on the formulation of beta k here. Beta k here is represent as the CG coefficient, right? So the idea of CG coefficient is actually come from the classical CG because it has the simple formula. And then for my study, I will just focus on classical and hybrid, right? Classical, it have the simple formulation, and hybrid means that hybrid methods mean it involves with the combination of two or more classical CG method. That's we call it hybrid CG method. Alright, so as you can see here for this table, this is the CG method or beta k. Beta k represent as CG, right? Type of CG. So this is class of classical method, right? That has been proposed by previous researcher. We have beta k hash with this formulation, right? Hash here represent as Hessenus and Staple, the name of the researcher that proposed this method. And then we have FR method, Fletcher and Reed. This is from proposed in 1964. We have PRP method, CD method, and the last one is RMIF method. Okay, so this is the class of classical method that has the most simple formulation. All right, and then as you can see, next page, this is also a class of classical CG method that has been improved. As you can see, the first one is this is the famous beta k, WYL. WYL stood for V, Yao, and Liu, right? So they improve PRP actually. PRP is the simplest one. If you see here, the formulation. So for WYL, it adds this color, which is norm GK divided by norm GK minus by 1 here, right? So they name as WYL. So similar to this one, you can see another improved classical CG method. We have YWH. This one is improved from WYL actually, right? If you see the difference here, the difference here is on the denominator, WYL and YWH. And then beta k AMRI, this one is improved from RMIL method, and then HRM method is improved from PRP method. Right, And then this is I just show a few improved classical CG method. And if you look at on, if you Google it, we have a lot of beta K in this class actually, right? So next is hybrid method, hybrid CG method. Hybrid CG method is a combination between two or more classical CG method. So the first one is known as TAS, right? TAS, beta K TAS. It is proposed by Toti Ahmed and Story in 1990, right? They are the first hybrid CG method, right? As you can see, it is combination between PRP and FR with this condition, right? And then next we also have beta K hash here. It is combination between label YL and also FR, and then they add a scalar here. This one is what is it? The parameter 2. Right. And then you can see this is another type of hybrid CG method, right? And okay, this is the previous existing CG method that has been proposed. So next I move to the CG method algorithm, right? For the algorithm, we will start with K equal to 0, right? So we start at K equal to 0, and here we choose any random number for the initial point as S0, right? And then we will compute the scalar of beta K, right? Beta K here is the CG coefficient. And then we will compute the search direction by using this formula. And also next we will compute the step size, which is alpha K. For our study, we will use both line search, SZ line search, and also in SZ line search. For in SZ line search, we will use Strong-Wolf line search. Next, we will update the next point by using the iterative method here, iterative formula here. Right, and then we will check the convergent test by using this this condition, and the stopping criteria is this one. Right, and then if the condition are satisfied, then we will get the solution point. Then the iteration process will be stopped. And if the condition is not satisfied, so it will be repeat with the next iterate point, right? S1 until we will get the solution point, the global solution. So our contribution for study is here at the beta K, right? For my research, I will introduce and I will propose another type of beta K, right, in class of classical and also hybrid class, classical and hybrid class. Right. So this is the problem statement that motivate us to do the research, right? First, is it the existing method is globally convergent, right? So from the literature, right, we have looked at some of the existing CG method does not converge globally, right? Means that they are not converged to the global solution. And then second, is it the method is robust, or is it the method is efficient? Robust means the method is able to solve various of test problem in different initial point and in different dimension, right? So some of existing CG method cannot solve the problem, the unconstrained optimization problem. And then efficient means that the method able to solve the problem with the small number of iteration and low CPU time, right? Low computational time. So from the literature, most CG methods are robust, right? But they are not efficient since they have a high number of iteration and also high number of CPU time to converge to the global solution, right? And so that we believe that a good method must possess both of these criteria. It must be robust and it must be efficient, right? And then number 3 is it the method is easy to be implemented. Means that most of recent CG method usually have complex complicated formula, right? And make it them difficult to be implemented, right? For example, another class of CG method, we have spectral. If we look at the formulation of spectral CG method, it will require another parameter, which is sorry, I'm not put the formula of spectral CG method. If you can see the spectral CG method, it have another theta on the search direction, dk equal to negative theta gk, right? So it's make the formulation going to be more complex. Okay, and then next, right, so therefore it is necessary to improve the CG method so it can be easily used, robust, efficient, and also it must be possess to the global solution, possess global convergence properties. Right, so this is the objective of my study. First, to introduce two improved CG methods of unconstrained optimization in the class of classical and also in class of hybrid CG method. Second, to analyze the efficiency of the proposed method, both classical and hybrid, with different line search according to their performance in solving some standard of unconstrained optimization function. And the last one, number 2 is for numerical part, and number 3 is to prove the sufficient descent method. To prove the proposed method satisfy sufficient descent properties and global convergence condition. Alright. So so in this slide, I just show you the result of numerical performance, right? So for the proving part, if you are interested to look at more on the proving part, you can refer to my paper. I have listed it on the last page of this slide. Okay. So next is this is the scope of the research. Just summarize what the scope of the research that will be used that is used in my study. So the research is under the field of optimization, right? And we are focused on unconstrained minimization problem. So if we have a case of maximization function or maximization problem can be converted to the minimization by using the negative function, negative here. And then for search direction, we use conjugate classical and hybrid for conjugate gradient, right? And then for step size, we use both line search, exact line search, and inexact line search. Exact line search will give the optimal value in terms of its accuracy, and for the inexact, it is approximate value of alpha k. But it is actually based on the theory, it is faster to obtain by using inexact line search compared to the exact, right? And then we do the theoretical part. We prove it. The proposed method is satisfies sufficient descent and also the global convergence. And actually, this is the important lah for theorem. If we propose a new method, so a new method for CG, right? You need to make sure that both of these methods are satisfied. And then for the numerical test, I will use 30 test function. 30 test function referring to the unconstrained optimization problem. Sorry. Right, with 4 initial points from the low to the height dimension, right? And then the numerical test will be tested by using MATLAB software, and then the result is in terms of number of iteration and also CPU time, right? After we get the result, we will analyze the result by using the performance profile. Right, next, this is the methodology. For the theoretical part, so our motivation of this study is come from one of the recent classical CG method known as RMIL. So this is the formula. Norm GK squared minus GK transpose GK minus 1 over norm of GK minus 1, right? So our motivation is this method will give the negative value, right? Negative value for this scalar function, right? So to prevent the negative value occur in RMIL, we propose another new classical CG coefficient, right? So this is the proposed method for classical CG, right? As you see here, I put condition here. So this condition will lead to the positive value, right? Yeah. Why we want to avoid the negative value? Because negative value sometimes it may cycle. The iteration will be cycle at the similar point infinitely to reach to the global solution lah, right? And then I add another scala here, which is referred to this one N here. Okay, this is the type of classical where it is improved from RMIL actually. And then another method is under the class of hybrid, new hybrid CG coefficient. So as you see in here, I will combine two classical method. I will combine the proposed method NRM and also another existing classical CG method, which is HS. So this is the formula of HS, right? So this method will produce the positive value. Okay, and then the name of both of this method, as you see, use NRM. N actually is my name lah, Nur Hamiza. R is my supervisor, Dr. Riwai, and M is my supervisor, Prof. Mustafa, right? So classical, I name it as NRM method, beta K NRM, and for hybrid NRM1, right? So our method also must be satisfy the convergence analysis, right? So as you see, any algorithm in CG method is said to be good in convergence if it fulfill all the convergence properties, sufficient distance condition, and also global convergence properties under any line search, right? So this is in theory. So for the numerical part, so both of the NRM proposed classical CG method and proposed hybrid CG method NRM1 are implemented on MATLAB, right? And it be tested on 30 test problem. This is the test function from the literature, right? With a variety of initial point and dimension from small to the large scale problem. And then the proposed method will be compared with the existing CG method. Here, I compare it with HS, RMIL, TS, and JSJ. So HS and RMIL actually is under the class of classical, and TS and JSJ is under the class of hybrid method, right? And then the result are taken from MATLAB. The result are taken based on number of iteration and CPU time under SZN strong wolf line search, right? And then we will test the performance by using performance profile. Performance profile is suggested by Dolan and Moore. And this is also is the foremost methods used to test the performance of CG method, right? So next we move to the numerical result. For the performance profile, as you see here, we have three parts. First is the performance profile of all tested method, right? By using SZ line search, all the performance profile for all tested method by using in SZ line search, and also the performance profile for comparison of NRM and NRM1 between SZ and in SZ line search. So this is my proposed method, right? And all the comparison will be looked at in terms of number of iteration and also CPU time. So this is the graph. the graph of performance profile of all tested method using a Z-line search with respect to the number of iteration, right? So the best method has the smaller number of iteration to converge to the solution, right? So as you see here, the black line represent my proposed classical CG method. Red line here is the proposed hybrid CG method, and then the green line HS, yellow line is RMIL. So green and yellow is from classical, and then blue line is for TS methods. Pink line is for JSJ. This is both of these from the hybrid CG method, right? So how to read the graph here? First, you can look at on the left hand side of the graph, right? The higher curve at left side indicate the fastest method, right? So if you look at here, the highest is represent the red line. So the red line here is NRM1 method, the proposed hybrid CG method, right? And then from the right hand side of the graph, we will see the percentage of test problem solved by each method, right? So the number of the highest percentage of test problem that can be solved is by using NRM1 method, followed by blue and pink. Blue and pink is THANS JSJ, and JSJ it come from the hybrid CG method, right? And then the worst is HS lah. If you see the green color here, it involve it only can be solved the less number of test problem, right? So this is performance profile by using performance profile of all tested method by using a Z-line search for number of iteration, right? Next, we look at on CPU time, right? Performance profile of all tested method using a Z-line search with respect to the CPU time, right? So if you see here, it's similar way on how to read the graph, right? The higher, the left hand side represent higher curve at left side indicate the faster method. From right hand side, it represents the percentage of test problems solved by each method. So if you see similar to CPU time, the result for CPU time complement to the previous graph of number of iterations. So if you see here, the highest graph from right hand side is red line, and the highest graph from right hand side is also red line, which is represent as the proposed hybrid CG method, right? And RM1. Okay, next is the result performance profile of all tested method using in a Z-line search. In a Z-line search with respect to the number of iteration. So based on this graph, NRM1 show the best performance in class of hybrid, right? If you see class of hybrids is red line, blue and pink line, right? Red, blue, pink and blue. And then NRM proposed classical method is show the best performance in class of classical. Black is the proposed classical. Green and yellow is the existing classical hybrid, right? This is from the left hand side. And from right hand side, the percentage of test problem solved by each method, the first, the highest percentage of test problem that can be solved is by using NRM1 method, right? Followed by the black one is NRM method, right? Both are from the proposed method. Okay, similar to performance profile of all tested method using in a Z-line search with respect to the CPU time. So the result here complement to the previous, which is similar to the condition in the number of iteration, right? And then the last one, this one is the performance profile for the proposed method only, right? NRM and NRM1 with respect to number of iteration, this one. And here is for CPU time, right? So as you can see here, if we compare, if we look at on the graph here, black and red here represent as the exact line search, and RM in the exact line search, and green and yellow is for inexact line search, right? So if you see here, the best graph, right? The best method is yellow one, which is hybrid CG method in inexact line search, right? And then if you look at in terms of CPU time, the inexact line search, the green color here, inexact line search is fastest compared to the exact line search, right? So it is agree from the previous researchers said that it is hard to get the optimal solution when we use the exact line search. But interestingly, both of our method, NRM and NRM1 method, still able to converge to the solution point. Either we use exact or inexact. But if you look at on the performance, yeah, of course, inexact line search is better compared to the exact line search. Right. Lastly, for the conclusion, so the proper CG method in class, new CG method in class of classical and hybrid CG method has been proposed respectively. Both based on the numerical result, both improved CG method show better performance compared to the existing CG method. Hybrid method outperform in the class or outperform the classical method. And then the performance of both improved CG method with inexact line search are more efficient compared to by using the exact line search. And then both improved CG method are theoretically proven to possess the sufficient distance and also global convergence, right? So all the research objectives have been fulfilled. So this is a few of reference that I use, and this is my publication. So if you are going to look at on part of proving, right, because it has long calculation there, so you can refer to my paper. So yeah, that's all from me. Thank you.
Terima kasih Dr. Hamizah. Okay, Q&A. Saya buka untuk para pensyarah bertanya soalan atau mohon pencerahan. Dipersilakan. Kalau ada soalan, diajukan sekarang. Mohon diajukan sekarang. Okay, Dr. Hamizah. One for your search direction, one of the method you use is Newton method, right?
Okay.
Instead of Newton method, why not you use what you call Halley method? Is it possible?
Again, Doctor?
Halley method. Halley.
Halley method.
Yeah. Is it possible to get search direction by using Halley method?
What's mean by Halley method actually?
Halley method actually is root finding like Newton.
I'm not sure about that one. Sorry, Doctor.
Okay. Any question? Ada soalan? Okey, jika tak ada soalan, saya cuma nak buat pengumuman. Kalau ikutkan tarikh sepatutnya untuk Kolokium seterusnya adalah pada bulan Oktober